right? Now, the tympanic membrane, it is formed by connective tissue core. The interesting thing about the tympanic membrane is that it is formed by the three germ layers. The outer surface is from the ectoderm, the core is from the mesoderm, and the inner surface from the endoderm. So that's why it's a connective tissue core that is lined by skin outside and mucous membrane inside. And it is at the periphery, it is attached to the fibrocartilaginous ring that will help you to fix that membrane into the tympanic part of temporal bone. Remember, you guys, when I told you the only part of the temporal bone, it is basically the bony part of your external acoustic meatus. It was the tympanic part. So in that tympanic part, you will get the attachment of the eardrum. Other than that, everything in your ear is related to the petrous part of temporal bone, except, of course, the mastoid wall. It's the mastoid part. And we said that the squamous is out of everything. Now, we will fix the eardrum into the tympanic part of the temporal bone. Now, what's important thing you guys need to know is that the eardrum is actually sloping from the top to bottom, posterior to anterior. That will take you to a very important thing is, can you guys see this animation? Can you see how the sloping, let me just try to clear markings. Can you guys see this arrow here? Can you guys see the arrow here? This is showing how the sloping of the eardrum is. Can you guys see the other arrow? This is showing you how you, as an ENT physician, need to pull the auricle in a posterior superior direction in order to straighten the eardrum if you want to see the eardrum or the tympanic membrane by an otoscope. And if you do so, you're gonna see a cone of light at a 5 o'clock position. Okay, so this is a cone, a reflection of light. You're gonna see a flaccid part on the top of the tympanic membrane. We call it pars flaccida, and you're gonna see a toot at this lower part, so we call it pars tensa. And this is actually the handle of Malleus, because you guys know that the three ossicles, the three small bones that are going to oscillate to transmit the sound waves from the external ear to the inner ear, all right, they are the Malleus, Incus, and Stapes. How can you remember that? It's the word mess, all right? This is the word mess. So the M is connected to the eardrum, the Incus is in the center, the Stapes is connected to the oval window above, because this is your oval window, all right, to the inner ear. So this is related to the outer ear, this is related to your inner ear, and this is what connects them together. So the Malleus, Incus, Stapes. The most important thing you need to know about Malleus is the handle of Malleus, because this is what is, you get to see it in the tympanic membrane, the handle of Malleus. And the most important piece of the Stapes is actually the foot process, because this is what sits on the top of the oval window. All right, you're gonna get the sound waves from here. This is going to oscillate. All of them are going to vibrate. The tympanic membrane will vibrate. They're gonna oscillate, and then they're gonna push against the oval window, and we're gonna talk about that as we proceed. All right, so I think that's enough about the tympanic membrane. So what do you think the innervation would be? We already mentioned that previously when we said that 5 is up and 10 is down, the auriculotemporal and the vagus nerve. So they are going to take care of the outer part of it. And we also talked about the middle ear cavity, and you guys saw the tympanic plexus sitting on the top of the promontory of cochlea that is actually coming from the glossopharyngeal nerve. So you don't need now any more memorization. You only need to relate to what we've already discussed in the previous slides. All right. Now, what about the pharyngeotympanic tube? So as we mentioned previously, the pharyngeotympanic tube is very important because this is the communication between the middle ear cavity and the nasopharynx. It's going to help in equalization of pressure in the middle ear cavity, because you guys, the Eustachian tube or the pharyngeal tympanic tube is actually closed. It is actually closed. But however, if we have any change in the pressure, all right, if we have a pressure change, it's already closed. So you're going to have the eardrum sucked inside. And in that case, you need to open that. And that is going to happen by thanks to these two important muscles, the levator palati and the tensor palati. Okay, you also have contribution from other muscles, but these are the most important ones. These muscles are going to pull on the cartilaginous part end of the pharyngeal tympanic tube, because remember when I told you that the outer 1/3 is bony and the inner 2/3 are cartilaginous. Okay, so that the two muscles from deep inside around the palate from here, all right, these two muscles are going to pull on the cartilaginous part, and they're going to, thanks to them, they are going to help. And this can be done by the Valsalva maneuver. This is exactly what I mean by this maneuver, and you can also do this by yawning. All right, that will help these muscles to pull on the cartilaginous part and help in opening of the pharyngeal tympanic tube, so that you can equalize the pressure on this closed cavity in order to equalize this pressure to the atmospheric pressure outside. All right. And another thing, important clinical note about this is that this tube is very important, because sometimes if a patient is left untreated from bacterial pharyngitis and his body could not actually attack these bacteria, this pharyngeal tympanic tube is very important, because that patient after some time will end up having otitis media. So you need to know that this is the communication that helped the bacteria to come all the way from the nasopharynx, all right, all the way to the middle ear cavity, all right? Now, moving to the next topic, which is the inner ear, and this is going to be the final part of the ear concept, all right? Now, what is the inner ear? Basically, your inner ear is what's going to help you to hear and balance yourself. The inner ear is formed by a bony labyrinth, all right? All right, so labyrinth in Latin means it's kind of a maze. It's actually a maze. You get into something, you exit another thing. So this is actually what we mean by the labyrinth. Now, we have a bony labyrinth, and that bony labyrinth is filled with perilymph. And inside the bony one, we have a membranous labyrinth. And inside the membranous, we have the endolymph. All right. Now, what are the parts of the bony labyrinth? The bony labyrinth is formed by a vestibule, and you guys remember that from my previous videos, that whenever I say vestibule, you have to know this what we mean by that in anatomy is actually is a wide entrance. If I have a wide entrance to something, the early anatomists used to call it vestibule. So this is your entrance to the inner ear. The vestibule is actually connecting anteriorly the cochlea to posteriorly semicircular canal. So this is what we have in the bony labyrinth. I have a vestibule, I have cochlea, and I have semicircular canals, anterior, posterior, and lateral. And the lateral one is bulging into the medial wall of the middle ear cavity, along with the promontory of cochlea. And remember the oval window and the round window? The oval window is actually the entrance to the vestibule, because I need to enter through the vestibule to get to the next station while transmitting the sound, and we're going to talk about that as we proceed. Now, what about the membranous one? It's nothing but these ducts and sacs. Okay, so we have ducts and sacs, the ducts and sacs, okay, and these are going to be filled with endolymph, and this is going to sit inside and be embedded in the perilymph of the bony labyrinth. And they have got the same names, all right? So you have the semicircular canals, you have the cochlea, and you will have these dilatations, and we're going to talk about that as we proceed. But if we talk about the dilatations of this ducts, And these sacs exactly in the vestibule, they are the utricle and saccule. All right. And if we're gonna talk about the widening at the end of the semicircular canals, this is gonna be actually the crista ambularis. All right. Now, as we proceed, we already talked about everything in this. I just sometimes like to type in some information to make your life easy, but this is nothing but we've just mentioned. Here is another picture that shows you the utricle, the horizontal duct we have, and the saccule in here. Um, and these are the semicircular canals, and here you have the ampulla. All right, so you have the ampulla. This is the dilatation that you have at the end of the semicircular canals, because here you are going to have your sensation, the sensory parts of your inner ear. Okay, so the most important things out of this all, if we talk about balance, the ampulla of the semicircular canals and the utricle and saccule, inside them you have the sensory organs. And the cochlea when we talk about the hearing, all right? And it's actually around 2/3 of a circle, each one of this semicircular canals. Sometimes I like to write down some information, and they are at a right angle of each other's. This is just an extra information for you guys if it's important for you to know. Now, again, this is the oval window in the vestibule, and this is a round window at the end of the cochlea here, as we transmit the sound all the way through the cochlea. Let's move on, all right, to talk about so again, here we have the same thing. The cochlea is a bony structure that twists upon itself around an axis, and that axis is actually your modulus, and we're going to talk about that as we proceed. Now, what would be the nerve? The nerve that you guys know that we have it's the vestibulocochlear nerve. The vestibular part is going to take care of the balance. The cochlear is going to take care of the hearing, all right? And they're going to emerge and come out of the inner ear from the internal acoustic meatus in the petrous part of temporal bone. This is an opening, and that takes you to the posterior cranial fossa to get you all the way to the brain itself, right? It takes you all the way to the brain itself, and we're going to talk about everything about this nerve and how we process this information in the brain when we explain the neuroanatomy module videos, inshallah. All right, now the inner ear, again, it has the semicircular ducts, utricle and saccule, when we talk about the balance, okay, and that is processed by, as I just said, the vestibular nerve. And the cochlear duct is the organ of hearing, and this is by cochlear nerve. All right, now there is a very important information which is sometimes confusing the students. It's basically when we talk about the internal structure of the cochlea, we have something called scala vestibuli and scala tympani and scala media. What is this actually? I want you just to think about the membranous part and the bony parts of the cochlea, right? Now, if you have a membranous part getting into a bony part, okay? Now think about this, as this is embedded inside of this. If I have a membranous part gets inside the bony part, and this is actually my media, this is gonna be my scala media, all right? Above that, I have scala vestibuli. Why did we call it scala vestibuli? Because this is the entrance of that is the vestibule. It's the entrance for the sound is gonna be by the oval window above. All right, so that's why we call this part above here as scala vestibuli. And now you're gonna have this sound waves transmitted through the scala vestibuli. Below the scala media, which is actually inside your membranous cochlea, okay, above it, we said that it's scala vestibuli. Below it, you have the scala tympani. There is a small part here because this is the end that is going to be as a communication between the scala vestibuli and the scala tympani. This is, you guys, what we call the helicotrema. Why is it important? It's important because I need to take the sound waves all the way. All right, I have here the cochlea. I'm taking the sound waves from the scala vestibuli. I need to take it all the way around, and at some point I need to return it back through the scala tympani and bring it back into the round window. So I need this communication between the scala vestibuli and the scala tympani all around the media. But at the end of the day, my purpose here is, as I move the perilymph outside, I want to move the basilar membrane that separates the scala media from the scala tympani, because on top of that, I have my hair cells that I want to activate and I want to hear. And we're going to talk about that into more details as we proceed. Okay, but here I just wanted you guys to know that at some point at the end, let me just change this color. At some point at the end of this thing, I have a communication between the scala vestibuli above and the scala tympani below, which is what we call the helicotrema. I hope that the drawing I made it easy for you to understand, because I know this is a confusing topic in the inner ear. All right, so Scala vestibuli is continuous with the vestibule. That's why we call it as such. The scala tympani, it takes you all the way to the round window, and it's covered by a secondary tympanic membrane because we want to close off the cavity, but we want some flexible kind of support, and that is by the tympanic membrane. So because it's tympanic membrane, we call it scala tympani. So what you have down is the tympani, the end, at the end of the transmission of sound. What you have up is the vestibuli. All right, and this is what receives the sound waves, and between them at some point here you have a communication, because you want to bring everything from one side to the other side and bring it all the way down to the round window. So this is communication, is what we call the helicotrema. All right, I hope